Okay, here's some exercises for objective 2, getting practice with that location principle. We're looking for sign changes where our function values are going from negative to positive or positive to negative. We know it has to cross the x-axis between those numbers. So here is your first practice problem, a quartic. Look at those numbers, 24 leading coefficient, negative 28. Start with those, rational zero test. I was real nice to you with that table. Take a look at that table. That should give you a really good place to start. So go ahead and pause the video. And you're back. Let's look at this. All right. That list of possibilities, very frightful. Look at them all. However, the table was really, really nice in that it gave you 2 automatically. The negative 1, go ahead and divide it synthetically. The 4, divide it synthetically. And then whatever you get left over, you have a quadratic. This time I couldn't divide by anything, so I went ahead and just factored it out. And there were the last 2, negative 1/4 and negative 7/6. So if I look at those, I can't get from this table that those are in there as zeros. And the reason why is because I'm only going up by integers there. So I'd have to decrease the increment so that I could see it switching from positive to negative. But if I look back at the list of stuff, of course we had our 1 in the list, our 4 in the list, we have 1/4, there it is, and 7/6. 1, 2, 3, 4. Hey, there's 4 answers here. 4 answers. 4 zeros. I wonder if that's significant. I wonder if it is. Okay. Let's look at the next one. Yeah. So on the next one, those leading coefficient and the constant term bumped it down just a little bit, but you do want to go ahead and list out the possibilities, using the rational zero theorem, because if you look at your table this time, I didn't give you any, right? Now you might be able to look at some sign changes and go, oh, there's stuff in between here and here, but I didn't give you any free ones. Ooh, can you handle it? Are you up for the challenge? Go ahead and pause your video. Okay, and now you're back. Now, that one may have taken you a little bit, huh? So let's take a look here. So the list of possibilities is not as big as it was on the last one, but you didn't have a very clear place to start, not like the last one. Sure, when I'm looking at the table here, I can see from 78 to negative 16, there's got to be something in between negative 1 and negative 2, so something in that list in between there. And then from negative 16 to 12, there's got to be something in between negative 1 and 0 from that list. Positive 12 to negative 24, same thing in between 0 and 1. And then the last one, negative 70 to 168, there's got to be something in between 2 and 3. So knowing that, I went back through the list and went, oh, it can't be 3 because that's outside 4, 6, and 12. That got rid of 8 possibilities out of those. Well, that was kind of helpful. Okay, and then I randomly chose something in between 0 and negative 1. I went ahead and chose negative 1/2. Divided it, and it worked. And then I honestly was not so lucky at the next one, so I probably had to do a couple more on paper. You don't see that work here. But 3/5 was the next one that worked, and the 3/5 is the one that's between 0 and 1. Divide that out, you get this quadratic. Everything's divisible by 10s. Go ahead and get rid of it. Use the quadratic formula on that. Look again. Those things are, what's the word for that? Conjugates. Yeah, they're conjugates. And there's my negative 1/2 from initially before, and then the 3/5. How many answers are there on this one? See, I got 1, 2, and this counts as 2 more, so there's another 4 zeros. 4 zeros. Again, I wonder if that's significant. Maybe it is. Maybe it is. All right, well, see you in class, guys and girls.